Hello everyone, here is a short video on why we have squares and this new thing called a square root. We can think of any number as a number of squares. Here we have 9 little squares, 1, 2, 3 across the top, 1, 2, 3 across the middle, 3 more on the bottom. This 9 area, 9 square units, represents a number. We can think of the square root, the root being what it grows out of. This 9 square diagram has grown out of this root of 3. We all know that 3 times 3, or base times height, equals 9. 9 is considered the square number. 3 is the square root of 9. To change the size of my square, to draw a square root of 4, 4 times another 4 gives me a square number of 16. 9 and 16 are known as perfect squares because you can see that all of the squares inside of this bigger square are perfectly sized. There aren't any chunks of a square. I can increase to 5 by 5. Here again, I get a perfect square. What happens though if I try to make a square area that isn't perfect, like say 20 squares? If you try to count out 20 squares, which would be 4 of these rows, 4 by 5 is not a perfect square. But if I try to get my area to come out to be as close to 20 as I can get it, you can see that it's not coming out very nicely. I can't hit a perfect square of 20. I get all these little chunks of square out here around the perimeter, which means I have a non-perfect square number. And the square root, as you can see, is incredibly long. Even if I could get this value to 20, this square root value is going to be what's called an irrational number. Even though it looks like it stops in this picture, my computer is only going to 13 decimal places. The actual value continues forever without any discernible pattern. We call the area here the square number. The length of the outside of the square is known as the square root. In order to help us with our writing of symbols, we have square root, which multiplies by itself the base of the square times the height of the square, giving me the square number. I showed the example where 5 times 5 equals 25. We don't have to use whole numbers or integers. We could use decimals, like 2.5 times another 2.5 would be 6.25. So if the square is 6.25, we say the square root of 6.25 is 2.5. If I draw a perfect square of 49 squares, hopefully you will figure out that the square root would be 7, because 7 times another 7 is going to give me a total of 49. We have this new symbol though, right? A new symbol I haven't shown quite here yet on the screen. It's for these circumstances, like with 10, where 10 is not a perfect square. And yet I'd like to talk about that number without having to go to an infinite number of decimals. So if I take this picture and take it back to try to get a size of 10, there's 9.99. That's really close to a 10. But look at this value. It's crazy pants. Nobody wants to write that down. And so we're not going to. We've invented a new symbol to help us with that situation. It's called the square root symbol. Here I'm going to insert the equation and put in this fancy, it looks a little bit like a division sign. Whoops, talking about 10. The square root of 10. Whoops, just trying to use my computer here. Don't mind the old man. Square root of 10 times the square root of 10 again is equal to whole number 10. So this little checkmark symbol represented that infinitely long decimal string. Let me show it to you again here. That's around 3.16 with a whole bunch of other digits after it. If I try to get an exact value for the square root of 10, it's not in decimal form, it's just never going to work. I get this infinitely long string of decimals that's hard to carry around. This symbol, however, is very easy to carry around. The square root of 10 in symbol form, right, being right here, the square root of 10 represents that crazy decimal. This is much easier to write down. It's much easier to calculate with. It's much simpler to label our pictures with. So we use the square root symbol when we don't have an integer value as an alternative. You will sometimes, however, see people write things like the square root of 49 without it being simplified. This is acceptable. It just isn't simplified. And if you know your square root vocabulary, you would know that the square root of 49 is just a very fancy way of saying the number 7. If I go back to my diagram and I make the area into 49, you can see I've got this labeled here, this length on the outside, as 7, but I could also call this the square root of 49.